Hey, welcome back. In this video, we're going to start our discussion of tabular data and how to work with and manipulate tabular data using pandas. So pandas is a package for Python that is specifically designed to enable efficient and intuitive operations on data that's presented as tables. And we'll see what that really looks like very shortly. The name pandas originally derived from the term panel data, which is very common in the econometrics literature and not all that common in a lot of other places. So this was a little obscure. I had to look that up myself. But the name pandas derives from panel data. So some programmers pronounce this differently. They say pandas or something like that. I say pandas because I like panda bears, and I like to imagine that when I'm computing with pandas, a small army of bears is actually running around and moving the zeros and ones through the processor for me. So here's an illustrative example of what's going on in my mind when I am using pandas to work with data. Okay, so when we go and work with pandas, the first thing we need to do is import the package. So let's go ahead and do that. You've noticed already that there are kind of standard aliases for a lot of packages in Python. So for example, np is standard for NumPy. PLT is standard for matplotlib.pyplot. Similarly, when we import pandas, it's very common and almost standard to call pandas PD. Okay, so import pandas as PD. So go ahead and run that. Now, there are lots of ways to get tabular data into Python. But really, the most common and most important way of accessing tabular data in most contexts is to read in CSV files. Okay, so remember that CSV files are comma-separated files. They have rows and they have columns, and you tell apart the columns by commas separating the different values. So a few weeks ago, we actually discussed how to read in CSV data into Python using the CSV module. And these are useful tools, but pandas is almost always going to be easier, actually, presuming that you want to treat the CSV as a tabular data set that you want to use. So we are going to use pandas to read in a CSV file. To read a CSV file, we use the helpfully named pd.readcsv function. So let's go ahead and do this. In this lecture, the specific data set we're going to use is the Palmer Penguins data set. And that's your data set for the course project. So my hope is that by working with this data set in the recorded lectures, we can help you build some familiarity with this data that will help you as you complete your project. So as you know, the data set, the Palmer Penguins data set contains data on 3 different species of penguins gathered in the Antarctic. Super fun data set, so let's go ahead and read it in. So this code block that I've already typed in, all this does is it grabs the data set from the internet where I'm hosting a copy of it, and then downloads it to a local file. This is all stuff that you remember or can remember from your lecture a few weeks ago on URL lib and getting data from online sources. So what we do in the first couple blocks is we import the URL lib module. Then we grab the data from online, and then finally we write it to a .csv file called palmerpenguins.csv. Having done that, we are now ready to load this data into Python as a pandas data frame. So let's go ahead and do that. We do, I'm going to call my data frame penguins. So penguins equals pd.readcsv palmerpenguins.csv. That's just the name of the file from which I'm reading in this CSV. I run that, it runs quickly, and it doesn't look like much has happened, but I do have a new variable. And my new variable is called penguins. And if I inspect it, I'm prepared for a lot to happen on your screen all at once. If I inspect it, I see that what I have is this really elegantly represented table of data. Okay, so I see that I have a lot of different columns. So for example, I have a study name column. I have a species and region, the island on which the penguin was found. And then I can even scroll here in pandas because there are a lot of columns in this data. I have various measurements of the body mass. I have flipper length for each penguin. I know what sex the penguins are. Notice that in some cases we might have some missing data. That's what these NANs mean. But overall, we have this like abundance of information about these cool penguins in Antarctica. Data science is dope. So when we're looking at this, we see, okay, we have rows, we have columns, and in our rows and columns, we can have different kinds of data. So remember that in NumPy arrays, it was essentially all numbers all the time. We could technically do some work with strings. We didn't do a lot of that. But even there, you needed to have a NumPy array with one data type. If it was going to be strings, it had to be all strings. In pandas, that's not quite true. The columns need to all have the same data type, but the data type can vary in the rows. So for example, the flipper length column needs to be all numbers, in this case floats, but the sex column can be, in this case, text, male, female, or NaN. And when I look at the rows, I see that each penguin has different kinds of data associated to it, both quantitative data like flipper length and text data like its sex. Okay, so this can look a little bit overwhelming when we see, okay, I have all these columns, I have all these rows. Python has actually even sort of trimmed the view here. So you notice we go from row 4 to row 339 so that we don't have to look at all the rows at once. In total, we have 344 rows and 17 columns. So what I'd like to do first is just like get a sense of what this data set is like, what's going on here, what is its shape, what is its structure. So let's go ahead and take a look here. So by the way, if you weren't sure what those columns were that say culmen depth and culmen height, those were right beside flipper length and body mass. Those refer to the shape of the beak or the bill of the penguin. So the culmen depth is the height of the bill, and the culmen length is the, culmen depth and culmen length give you the length and the height of the bill. Okay. So let's go ahead and start investigating our data frame. What is it that we have here? So a nice simple thing we can do is very similar from NumPy. We can ask for the shape. And when we ask for the shape, we'll be told the number of rows in the data set as well as the number of columns. Unlike in NumPy, where we always have, where we can have an arbitrary number of dimensions, we can have 3 or 7 or 100 dimensions in our data. In Pandas data frames, we always have 2 dimensions, and we can always think of them as rows and columns. Okay, so this is pretty easy. We can get even more information. Specifically, we can get information about the data type of each column using this nice dtypes attribute. So dtypes. When I do penguins.dtypes, I'll get a list, and not literally a list, it's a list representation. I'll get this nice visual representation where I see each column name as well as the data type in that column. So I see that I have some float 64 columns. I have one int 64 columns, so I have some integers and some floating point numbers. When you see object in pandas, that usually means string. There are some exceptions to that because you can store weird things in a data frame if you want to. But in context, pandas will usually read in strings using the object data type, which means it's being very agnostic about what kind of data that is. This is fine. It's possible to give string columns a dedicated data type, but it's not really important enough for us to focus on here. So when we use dtypes, we can see that we have some integers, we have some floats, and we have some string type data. Okay, finally, a really easy way if you want to get a quick numerical overview of your data, you want to summarize the numerical columns like the floats and the ints. A nice way to do that is the describe method. So I'll do penguins.describe here. Unlike dtypes and shape, describe is a method, not an attribute. So I need the parentheses. So when I describe, I'll get this nice little numerical summary. Here, if you remember, I had a lot more columns than this. What's happened is that I've excluded all of the text columns. I'm just not even considering those at all. I'm instead considering the columns that have ints and floats in their data types, and I'm getting a whole bunch of information about them. So for example, I can just read off the table. I have my body mass here. I can just read off the table the average body mass and the standard deviation. I can see the percentiles of the body masses here. So I see that I have a whole lot of numerical information summarized in a very nice, easy to read, but compact and dense format. So if you just want a quick view of what the numbers look like in your data, describe is a nice way to do it. Okay, I want to now start talking about the parts of a data frame. So a data frame has 3 core parts, and we're going to talk a bit about columns today, and then rows is a bit more subtle, and that'll be the context for our next lecture. So the parts of the data frame are the column names, the index labels, and the data. Okay, so the column names I hope is pretty self-explanatory. Those are just the names describing what kind of data that you have in each column. Makes sense. The data, I hope, is similarly pretty simple. That's actually like what the value is in that column in a given row. The index labels are a little bit tricky, but for now you can think of index labels as being the row numbers. Okay, so we can see in this diagram here, the index labels in this illustration go from 0 to 9, so that's the first 10 rows. And you can think of the index label, for example, index 1 is just a name for that row in the data. Okay. What's really important when working with Pandas data frames is being able to extract different parts of the data frame. So being able to extract a certain set of rows or being able to get only a certain set of columns. Rows are a little more complicated. Again, that's next lecture. Let's work on columns right now. So we are going to figure out how to select some columns. So the easiest way to select one column is just to pass the name of that column to the data frame with square brackets. So in this way, we're actually using the data frame as kind of a dictionary whose keys are column names and whose values are the data in the columns. So for example, I can do this. I can do Penguins Island. So when I do Penguins Island, I say, hey, please give me the column that has name island in the Penguins data set, in a very similar way to saying, hey, please give me the value that has key island in a dictionary. So I can use a data frame like a dictionary to grab individual columns this way. Small technical point is that this result is, you'll notice it displays a little differently. It's actually not a data frame, but what's called a Pandas series object. This is not going to be super important in this course, but just like note in the back of your mind that something slightly different is going on here. For syntactic reasons, if you really want a data frame, you can actually put island in its own list, just so I'm saying, hey, I want the list containing the one word island. And now the result is, again, a Pandas data frame rather than a Pandas series. Not super important. Just know that if you really need your result to be a data frame, you can put it inside a list. Okay, why would you put something inside a list here? Like, why is that logical behavior? Well, it's actually because under the hood, what Pandas is doing is it says, hey, if it's a list, I'm going to return all of the columns asked for in that list as a new data frame. So what this means is that above, I said, hey, I want all of the columns in this list. There's only one, but I got it as a data frame. Often more usefully, I can select multiple columns at a time very simply by putting their names inside a list. So for example, I'll do penguins, then first set of square brackets. This first set of square brackets says, hey, give me some information from the penguins data frame. Second set of square brackets, this set of square brackets says I'm making a list. And let's say I want the species and I want the region and I want the island all in a new data frame. And that's exactly what I get. So I can pass a list of column names to the Pandas indexing and get myself a nice new data frame that has only the columns in it that I asked for and excludes the ones that I did not ask for. Okay, that's it for our first lecture on Pandas. We have loaded in the Pandas library. We have used it to read in some CSV files. In particular, we've used it to read in the projects data for this course, so hopefully that'll be handy for you. And then we have begun to slowly explore Pandas and see what kinds of objects we have in our working space now. We've seen a few different parts of data frames, as well as how to subset them by column. In the next lecture, we're going to focus on manipulating the rows of a data frame, how to get rows that satisfy certain criteria, for example. That's coming, so stay tuned.